Ross is going to explain the origins and the geology of the salt beds and some of the history of brine subsidence. I came to an event here last August where Rosalind spoke about, as part of the Saltscape partnership, and I learned all about Picknere and Holford Moss and Billinge flashes and Ashton's and Newman's flashes. It was just great stuff. So I'm delighted to have her here today. Thank you very much.
Thank you very much. Right, I'll do the advertising before I begin. I was involved in the Saltscape project and we produced various leaflets, and that's because I'm a member of the Cheshire regionally important geodiversity sites. That's why that's up there as well. And the map has come from the Saltscape project that was going for 4 years, and it finished last year, in fact. But we produced a whole series of leaflets, and there's copies of them, they're free over there, and you can get information about Ashton's flashes down the road, Adelaide Miner on top here, and Picknere on the front, and also Billinge Green flashes, which is what I'm going to talk a bit about today. And there's also leaflets that we produce, which are free, about the 3 salt towns that we've got. I haven't picked up the device. Northwich, Winsford and Middlewich. So there's trails about the geology through that as well. So that is my publicity bit. Right, done some notes, and I think there's 4 lines here, and that should get me going, I think. So what I'm going to talk about is the diversity of Cheshire's salt landscape, and that's where the term saltscape has come from. It's the geology of the rock salt beneath our feet, and I brought some lumps along here. So if you go down from here within about 50 or so metres, you would have hit the top bed of the Northwich Headite Formation, the Northwich salt bed, and then you've gone down and you would have hit the mudstone underneath that, and then you would have hit the bottom bed, which is, as you can see, is white salt, isn't it? And as this is a talk about white salt, most of the salt comes out of the ground, and it's this colour, because it's got little bits of fine mud and silt that's been blown into the desert area, so it gives it the red colour, iron-rich material coming in. So, luckily it's not raining or damp in here, because they would start to dissolve. But the rock salt beneath our feet is the source, the feedstock for the white salt industry, and it's the source of the wealth of this part of Cheshire as well, and also the chemical industries of the northwest as well. So I'm going to be talking about the geological reasons why the rock salt is here, and also the geological reasons why the ground beneath us doesn't always stay where it is, and why it's sinking. And where we are now, it is sinking. It has sunk in the past and it is still sinking. Kew University have been monitoring the canal along here for the last 20-25 years, and there's a cavity beneath us that is growing and growing, and the land is sinking. However, Northwich knows how to deal with it. So just, right, so Tony's kindly going to press the buttons for me. So my talk's going to go back an awful long way. It's going to go back 220 million years ago, and that's about the last time salt started forming here. Been forming 20 million years before that. And this is when at the same time the dinosaurs were starting to evolve as well. And then it will also go on, next one Tony, and again please, 20,000 years, when our patch of Cheshire actually looked like this. It was covered with an enormously thick ice sheet, and so this would be the mountains of Wales, and Cheshire would be underneath that ice sheet about 1,000 metres thick, something like that, an enormous amount of snow and ice. And then another couple of clicks, please. And then I'm also going to, another critical date is we've had 2,000 years or more of continuous salt industry in the area. I think it must be quite unique in the country. The salt industry has been going for since pre-Roman times, since the Iron Age. It's been going on from here, probably before that as well. So, so now, where is the salt? The salt is, the first map I showed you, that green area, is what is known as Saltscape, and it was spreading from Northwich in the middle down to the south to Winsford, and Winsford here. It was sort of covering that area there and up to the Mersey Basin as well. But the salt actually in Cheshire stretches along a whole lot of the eastern part of Cheshire, or mid-Cheshire, the eastern part, and southern Cheshire, and it goes into Shropshire, and it actually goes into Wales when you get across to, I think it's called Lower Witch, over in that area there. Salt also occurs near Fleetwood in the Pre-Salt, not very far from Preston New Road, where fracking is taking place. And it also occurs in Barrow Furnace Wall, the Isle of Man, and there's a salt mine in Northern Ireland, and also salt is mined in Yorkshire, in the Bulby Potash mine. And the symbols at the top, you've got a little triangle showing you where there's rock salt mines. So we've got Winsford, we've got Northern Ireland, and we've also got Bulby. And then the little round circles is where there has or is a brine field. The brine fields are operating is the one at Holford and the one at Warmingham, and there used to be one just down the road that's stopped about 10 years ago where they had a brine pumping area. So next one please. Now I thought I'd explain the geology, and this is very simple. I brought the jam jar along with me here. The geology of the salt landscape in Cheshire is very simple. You have to have solid rock, and the solid rock is this is solid rock here, it's rock salt. Above that you have loosely compacted materials, sands and clays. These are brought down by the glaciers and the rivers, where if you press another one, thank you, that the junction between the loose sand and clay that is above the solid rock salt is called rockhead. And it could be above solid rock, so it could be the loose material, sands and clays above the granites in Lake District would also be called rockhead. In this area, if you press it once again, it gets known as wet rockhead, because the salt is so susceptible to water. If I poured a glass of water over that, put it in a bucket of water, it wouldn't exist by the end of this talk, I should think. It dissolves incredibly quickly. So the water, and the water is the rain and the rivers, can get through the loose sand and the gravel, and when it hits the salt, the rockhead then becomes wet, and we are sitting on the wet rockhead here. And if you press the next one, what develops then is the salt turns into brine, and you get underground streams or brine runs. And if the surface of the rock, the solid rock, is sloping a bit, these brine streams will run down there. So a lot of people in Northwich know the term brine stream or brine run. And these are natural. So next one please. So I'm going to go through my time scale I've got here. So how did this wonderful stuff here that was an incredibly useful chemical form? Well, 220 million years ago, this is what Cheshire looked like. We were a shallow salt lake, and the temperatures were so high that the evaporation exceeded precipitation, i.e. it was always very, very hot, not much rain came in, and the water evaporated. So next one. And this is...
Yeah. Move on. Perhaps I'm not the only one wondering this. What causes the hexagonal shapes?
That's as it evaporates away. It's, when you get mud cracks, it's the same sort of thing that if you get sort of a body that's all consistent, there's sort of no variations in it, when it dries out, it tends to form hexagonal shapes as well. So when mud dries out, you get hexagonal mud cracks. When lava dries, you get hexagonal lava columns like a giant's causeway. So, organ pipes and things. So, and if you go underground in Winsford Mine, you can still see these. If you look up the roof, you can see those hexagonal shapes, and they're enormous. Some of them as well. Right. So where were we 220 million years ago? Well, the geography is completely different, and for some reason the world was this strange rugby ball shape, but it wasn't. I mean, this is just an exaggerated thing. We were still a sphere. But where Cheshire, what ended up as Cheshire was just north of the equator, and all the continents were stuck together as what is known as Pangaea. Gea is after Gaia, the mother goddess, so it's all the land was in one place, so you could have walked from what was going to be Russia, all the way around to South China and Siberia, and down to the South Pole as well. But we were just north of the equator. So the next one, please. And this shows you a little bit further on. The salt beds were forming in the geological period known as the Triassic. Well, everybody's come across the Jurassic because of Jurassic Park, when the dinosaurs were at their optimum and roaming around. Well, in the Triassic, the dinosaurs were really starting to evolve and diverge into the two lots. The lot that we still have the birds and the other lot, which I'm not quite sure what they are. So all the continents were together, and we were about 15 degrees north, and it was tropical, but it was a desert, so there was very little rain, so it was very arid. But what happened is the plates started to break up, and there were fault-controlled basins, so you can roughly see where the Atlantic is going to appear, coming through here, the Arctic down to the Atlantic running through there, and then the Indian Ocean coming through there. So it started to break up. So next one, please, shows you in even more detail what was happening. The red spot is on the Cheshire Basin there, and you can pick out Scotland and Wales and Cornwall down at the bottom there, and Ireland here. And the Cheshire, as the plates were starting to pull apart, the Cheshire Basin kept on sinking and sinking and sinking. And first of all, because it was arid area, massive sand dunes started accumulating in it. The winds were blowing from the east, and massive sand dunes built up. And you can actually see these sand dunes as you drive along the M60 at Stockport. You're going through those sand dunes, and they're all sloping down towards you. You can see these sand dunes at Alderley Edge and on the Wirral and in the Mid-Cheshire Ridge as well. Occasionally it rained, and there were gradually, rivers came in and spread back beds of gravel. And as the mountains wore down, the next one, please. Now, I don't know whether you can see that clear enough, but there's the Cheshire Basin there. All the brown areas are hilly areas as the mountains have worn down, but we've still got land everywhere. The blue areas is where the sea is starting to encroach in. So between Ireland and Wales, we've got the Celtic Basin, and this is going to end up as where the Irish Sea is now, but that sea was getting into Cheshire. So the sinking basins were starting to be flooded, and they were flooded just shallow, just a few tens of centimetres, arms of the sea forming salt lakes and lagoons. And also they were bringing, muds were coming off the hillside, when there was occasional flash floods coming in, bringing muds into the basin there. Red mud would settle out, and I have an example of the red mudstone here that was settling out. A lot of it was also blown in by from the desert as well. It'd be very much like the centre of Australia, that sort of thing. It would be like that, with salt lakes as well. And it was very hot and arid, and great thicknesses built up of this mudstone, which is termed geologically the Mercia mudstones, because we are in the Anglo-Saxon kingdom here of Mercia. The sandstones below are known as the Sherwood sandstones, because they occur in the Sherwood forest as well, so it's nice to have these slightly romantic names about them. So the climate was so hot that the lakes frequently evaporated and left behind this solid salt with these great polygons, as I said, with crystals as well. And it's very susceptible to water, so whenever it rains, the salt would dissolve again and then crystallize. And when it dissolved, the mud would settle out at the bottom, and you get purer and purer salt forming. So next one, please. So the Cheshire Basin, 220 million years ago, was a result of where Cheshire was then, or proto-Cheshire was. Great piles of mudstone and salt built up to about at least 50,000 metres thick, so that's 4,500 metres thick of it. The salt beds, the ones that we're sitting on now, are about 200 metres, that's 600 feet of salt and mudstone. That's the upper salt bed, the lower salt bed. There's a higher one that's been eroded away from here that's about 300 metres thick, 1,000 foot of salt. So an enormous amount of salt was built up. And then the climate changed, and with plate tectonics we moved a bit further north, so that's what happened next. So 65 million years ago, when the dinosaurs popped their clogs, Cheshire was still under a shallow sea. So here we are, here's Cheshire here, and we could still, you know, well, the dinosaurs could walk from what is Britain through Scandinavia to Greenland. So that's why Tyrannosaurus rex is found here and in Britain as well, because there wasn't the North Atlantic between us. So next one, please. So what's the Cheshire Basin like now geologically? This is where we get very technical. I just love my maps with wiggly lines over it here. So first of all, there's Liverpool. We are here, so Northwich is here. This is the Pennines. Where you haven't got anything is the Pennines here, and this is Wales over here. In the middle bit there, you've got a basin that is full of sand, first of all, and this great thickness of mudstone and salt, and these are in metres, so it's 4,000 metres. So I live just about here in Lostock Green, and the bottom of the basin is about 3,900 metres beneath where I live. Where we are here, it's probably about 3,600 metres. So it's an incredibly thick basin, and it's cut by major faults. When you drive to Macclesfield and you go up the hill, you're going up a fault that's equivalent to the San Andreas fault, which is this red rock fault, because the coal miners used to mine through the black rock, and they'd hit the red rock, and they know they'd run out of the red rock, or these mudstones and sandstones, and know they'd run out of coal. And that fault goes all the way down to Shrewsbury, to Church Stretton, and all the way down to Pembrokeshire, eventually a major fault. So next one, please. And then if you do a slice through it, a slice from west to east, so we're going from Chester to Leek. I've got this off the internet from INOS, and it's all about their fracking licences. But you can see you've got the depth below the basin here going down to 20,000 feet, and we've got it there in kilometres. So when I was talking things of 4,000 metres, that orange area is the Triassic rocks that have the sandstone, and then the mudstone and the salt. And the salt layers I put in at the top up here. So there's Chester, there's Northwich, and then there's Leek. So we're in this area here. Just of interest, Upper Bowland Shell equivalent, that is the primary target, this where we are running through for fracking. Right, next one please. So the Cheshire Basin today is an important geographical feature and also meteorologically. You always hear about the Cheshire Gap. This is a meteorological map, and you could just about pick out where Anglesey, and there's the Cheshire Basin. And this is a snowstorm that's coming through on Tuesday the 5th of December 2017. It wasn't the beast from the east, this is the beast from the north-northwest, I think. And what I was surprised about is the snow in centimetres per hour was expected to be about, I think it's coming in about 2 or 3 centimetres an hour. Well, that's an inch an hour we're expecting to come in. I can't remember what Tuesday the 5th of December was last year. But when you get, we've got salt in the ground, and we've got snow coming in, and we've got rain coming in, it's funneled down, and so if you add that onto salt, it disappears. Salt loves water, it dissolves readily. Next one, please. So, if we look at geography type now, and this I think has come from, brine compensation, or the mineral planning, what you call it, it's Cheshire, the old Cheshire Council mineral assessment thing. But it's showing you, here are Widnes, Warrington, that are now part of Cheshire, going down to Northwich and Winsford and Middlewich. The dotted areas is the high ground, so we've got the Pennines around here, we've got the sandstones of the mid-Cheshire Ridge, we've got Alding Edge sandstones, and in the middle bit here we've got the mudstones and salts, but we've got the River Weaver draining in through Winsford and into Northwich. We've got the Dane draining in from the Pennines into Northwich, and we've got the Wheelock draining southeast Cheshire and Alsager, joining at Middlewich and coming in there. So it's an awful lot of rivers and meeting where the salt is near the surface. So that's more water. We've got rain and snow coming in, and we've got surface water as well. So next one, please. So where does the water meet the salt? Now this is a geological map that I've got here, Well, it's a geographical map and geological map. The brown areas is the higher land, so you can see the witch towns of Northwich, Middlewich and Nantwich. The grey areas, through here, both the darker grey and the lighter grey is where the salt is occurring in Cheshire. So it's a vast area of Cheshire that is underlain by salt. There's reserves and reserves and reserves galore. Or should it be resources? Resources, it should be. Resources, you know they're there, but not exactly how much. Reserves is when you've actually quantified it. So the ones that you've got to look at is the wet rockhead. That is the important bit coming through here. And I think I showed you a picture of what wet rockhead with those jars. So that is where the salt is just below the surface, 10 metres down, something like that, covered over by loose sand and gravel and clay, and so any water can get to it. Right, next one please. So, how do we know all the stuff about the local geology? Well, it's basically thanks to the white salt industry. And I'm so pleased I'm going to have a look at the Murgatroyd stuff here, because it's one of the, I don't know whether you can have an installation as a hero, but it's a brilliant, the shaft is a brilliant geological source of information. This is showing you the Murgatroyd works in Middlewich, and it says 1899. But if you go back 10 years before that to 1889, that is the important date when that shaft was sunk. Geologically, it proved there were two salt beds, and it proved the King Street Fault existed. Now those are very important things geologically for the development of the whole salt industry. So next one please. So this is, it's amazing what you can find on the internet. And I found it once, and I tried to find it last night, I couldn't, but at least I downloaded this paper. By Twigg, in 1961, he talked about the story of the Murgatroyds. And the Murgatroyd find, they sunk this shaft, was really remarkable because it was the first time they'd hit in Middlewich solid salt. They hit solid rock salt here in 1670, something like that, just up the road from here, not very far. But they only had brine in Middlewich, but when they sunk this shaft in 1889, they hit solid rock salt, and they did some tunnelling into it. They didn't want the workmen to know where the salt was, so they made sure they twisted around when they went down the tunnel, they went off in whatever direction. But the surveyors knew exactly where it was. I think there was something about going under the railway line when they shouldn't have been, but that does happen in geology, in mining. So what he found out, there was a fault. It was the fact that the geological faults had broken the continuity of the salt, and it wasn't just a continuous layer underneath the ground, or just a layer of brine under the ground. And what was interesting, there was a shaft, the Ammons shaft, which only 50 yards away from the Murgatroyd shaft, that went down to the same depth, but there was no salt in it, and also virtually no brine in it. So obviously the salt had gone missing in 50 yards distance. So the next one, please. This is what geology is basically recording your rock types and putting little spots. In this case, the little spots are all black for where it's solid rock, rock salt, and then you join the dots up, and then it's like a three-dimensional jigsaw puzzle, and you join the dots up. So what we've got here is out of a publication by Albert Calvert, 1915, Salt in Cheshire, and I do urge somebody to get it reprinted and have it on sale here, because it's a wonderful book. You can download it off the internet. But this is a cross-section from Northwich to Middlewich to Sandbach to Alsage and Launton. So that is the ground surface as we go further from the northwest to the southeast. It rises. There's the sea level through there. And these are all the shafts and brine wells that have been sunk in the area, and where they've recorded rock salt and brine. So Northwich area, and I think we've probably got Newman's, which is just down the road, Marston, which is just next door to us here. They've sunk it, they've hit two beds of rock salt, they've hit an upper one, which is that, and they hit the lower one, which is the white one there. Lots of rock salt and brine. When you go to Middlewich, on the eastern side, they've hit rock salt in Murgatroyd shaft, but in the Ammons one, they've got no salt there. And then in Sandbach, not much salt, but very deep down, and in Launton, some more salt. And what you do is you match the thickness of the beds and how much mudstone's in it, and you get their fingerprint, and you can match that fingerprint. So the next one, please, if we keep on pressing it. That's the Northwich halite in Northwich. Halite is the posh name for rock salt. And then underneath Middlewich and Sandbach, the Northwich halite has been found in 20th century drilling, like for the warming and gas, the brine field and gas field. It's actually deeper. And then if you press it again, that underneath Alsage and Launton is the Northwich halite. And as you can see, it does a little bit of a jig. So if we just press it again, in Middlewich and Sandbach, that they found the rock salt beds there, those are the ones that are about 300 metres thick, had all the similarities of the same rock salt beds that occur in near Nantwich, a little community called Wilkersley. So Wilkersley is the whole formation name for the Wilkersley halite. And you can, but the Wilkersley halite is missing above the Northwich above in Northwich, and it's missing in Alsage because it's been eroded away by the ice. So this is where you start joining things up. So if you press again, Northwich halite, and then press again, you can see that the Northwich halite has sunk. And then you can start interpreting that, and this is, if you press again, that is where the King Street fault is, and again, and that is where the Mobley fault is. Now you're all familiar with the Rift Valley, aren't you, in Africa, where it pulls apart. Well, Middlewich and Sandbach has got their own little Rift Valley as well, you see. The crust of the earth has pulled apart, and that piece of ground that's holding the Northwich halite and the Wilkersley halite has sunk. So under Middlewich and Sandbach, you've got 2 lots of salt. Underneath Northwich, we've only got 1 lot of salt in the major formation. This one is 200 metres, this one is 400 metres, this one is 200 metres, and that's about, obviously, this is not representing it. This one, there is about 300 metres between them. Right, so if we go on to the next slide, now this is, the sun has just come out on the slide that I probably is my most didn't want to look at, so I don't know how these things, the blinds will come down. But this is now, you've got all these boreholes and shafts and information, and you can then plot it onto a map, a 2-dimensional map rather than a cross-section, so that's better. Should complain about the sun. So it's now starting to appear before your eyes, and this is how geologists work. You get the information, and a model starts coming before your eyes. So the salt towns, Knutsford is the salt town, Northwich is Winsford, Middlewich, and Sandbach. Knutsford, there's Tatton Mere, and there's also Melchett Mere. Melchett Mere is an artificial mere. It's caused by pumping. Probably from Northwich and from the Lymm area, and it was named by Lord Egerton after a fellow briner called Melchett, Lord Melchett, not the Lord Melchett of Blackadder, different one this is. So Melchett Mere is Subsidence, and Subsidence is still active there. If you drive to Tatton Park, as you go up to the hall from the Tatton Mere, there's big Subsidence scars that are still active through there. Right, so this is a map, and this strange purply coloured one, I've had to cobble it together from 4 different maps from the British Geological Survey, and they use different colours of the maps for some reason. That purple area is where the salt is near the surface, the wet rock head. And as I said, there's 2 layers of salt. There's a Wilkersley halite. So if we press the button, we should have a Wilkersley halite appearing between Middlewich and Sandbach, and a lower one, which is the Northwich halite, which is between Winsford and Middlewich. And you press again, and it's also between Northwich and Knutsford. You can start to see these areas of water that are standing out. These are where the salt has dissolved and substance occurred. Those ones there are the waistline beds for the Lost Rock works, so they're not subsidence those. You can ignore the full geological sequence down there, but it's all in the Mercia mudstones, but we ignore that. Right, so next one please. Oh, and of course, where it's dislocated, it's because we've got the faults going through. So there's the King Street fault coming down there, the Motherley fault, and one more, and Winsford likes to have his own fault as well, so it has a Winsford fault too running through there. So that is the geology. So really, where you're going to get subsidence is where the rocks, the salt is near the surface. So I've looked at 220 million years ago, the geology that's resulted from that. I'll now go on to 20,000 years ago, which is just recent in geological terms. There would have been folk like us around, but they wouldn't have had the advantage of plastics and computers and all those sort of things, but they managed very well themselves. They could hunt mammoths and those sort of things. So, next one please. So this is what the world looked like, and at least it's gone from a rugby ball back to a football, so which is quite nice. And so 20,000 years ago, the area, a lot of the northern hemisphere and the southern hemisphere, that we're not looking at here, were covered by ice. So this is Britain down here covered by ice, and there's Cheshire right in the middle there. So next one please, and this is a bit of more close-up of what it looked like. So Cheshire is again here. So this is when we're talking about 1,000 metres of ice. Over Scotland, they had 2,000 to 3,000 metres of ice. When it all melted, Scotland sprung up, actually, so which is because the weight of the ice pushed it down. Right, so this is where we are here, and this was 23,000 years ago. By 18,000 years ago, it has started to melt, and as you can see, this is Cheshire. You're starting to get water coming off the ice. It's also flowing under the ice and down and starting to form the Irish Sea, the approaches to the English Channel and the Irish Sea. And as it melted, the Irish Sea started coming in, but water was flowing under the ice and down that way. And it's this water under the ice that's important for our subsidence in this area. Right, next one, please. So when the ice sheet melted down, it left behind loose material, sands and gravels and clays, and the boulder clays, which is what our garden is. When you dig down, you always get lumps of rock in it, and it's usually lumps that's come down from the Lake District. You pick out granites from the Lake District. So this is just going through the timescale quickly. This is 16,000 years BP, nothing to do with British Petroleum, before present. So the ice sheet was coming in, so this is the salt area underneath here, and there's the Pennines, and there's a little ice sheet there. It was bringing in boulder clay, pushing in front of it. Then the next one is 40,000 years ago. That ice started melting, and when you have ice, it's quite a cold, arid environment. You get a lot of wind coming in, and this blew in the Chelford sands, and the sands, you see it's sand match, and Cranage is all built on these sands as well. And there's actually trees growing in it. So you've got a mixture of boulder clay with sands on it. And then about 20,000 years ago, there was another slight advance of the ice. It only got down as far as Wolverhampton and stopped. And then it started melting. It left behind the boulder clay and sands and gravel, and the water underneath it cut very deep channels as well. So we've got quite a mixture, and this is what I've got in the jar here, of clay and sand sitting on top of the salt. This unconsolidated material is known by a general term of drift. There's solid rocks, solid geology, and there's drift. Right. Okay, next one. So now this is, I do like my complicated maths. When the ice sheet melted down, the ice was still pretty thick. The water underneath it was under pressure, so it's like having a jet-powered thing that you clean your patio with. This time of year, isn't it, starting to get very green and all that sort of thing. And it actually eroded under the ice great, deep, it says here, subglacial meltwater channels over deepened depressions. They're known as tunnel valleys. They're underneath the ice. It's what's happening now underneath Greenland and underneath Antarctica. So when they talk about massive deglaciarization, it's all this water rushing out, and eventually the whole ice will collapse in on the top, and then the ice sheet will go. So, and as you can see, here we are in the salt area. There's the River Dane coming down, the River Weaver. There's a tunnel valley that's running down here, going in, and then flowing into what eventually ends up as the Irish Sea. And there's ones underneath the River Mersey, the Bollin, the Douglas up near Wigan, and under the River Dee. All these were draining to the north. So there's deep buried valleys. They are 50 metres below sea level, the one that we're sitting on now. Northwich is sitting right on top of that. It goes 50 metres below sea level. There's also ones around Sandbach, but they're flowing south, so it's Ettley Heath to Crewe Tunnel Valley. And they drill boreholes in Crewe, and they haven't reached the bottom of the valley there. It's about 100 metres or plus thick, so it's high pressure stuff. This is important for the salt industry. Next one, please. So, what you're looking at, and again in my little jar that I brought along here, that sand and clay and gravel in our patch here is deposited in the tunnel valley. It's about 60 metres thick. It's full of saturated sand and gravel sitting straight on top of the water, on the salt. Those tunnel valleys are like aquifers, underground aquifers. They're channeling water down all the time. So even without humans around, there is water hitting the salt is dissolving, it's a natural brine run. We're still sitting here, even if we stop brine pumping, we're still going to get salt solution because fresh water's coming in all the time. Next one, please. So, the Saltscape subsidence, you can spot where it's going to be if you've got your sand and gravel sitting on top and filling up your deep glacial tunnel valleys with brine runs in it, and it's wet rock head above shallow rock salt. And I think you can see that this whole area here is where the salt subsidence is going to take place. And if you press the buttons, we should go through the sequence. So, this is where we're sitting now. We're in the middle of an enormous area of salt subsidence. You've all driven through it if you're coming from whichever direction you've come through an area of salt subsidence. Next one, Tabley or Tabley Mere is salt subsidence. I haven't got Tabley on there. Next one is right down between Middlewich and get on to the even more complicated ones. I think that's a sign for me to hurry up, isn't it? Yeah. So we've got that one there, and then the ones between Middlewich and Sandbach, and then the ones to the north of Middlewich in the Dane Valley. There's a lot between Winsford and Middlewich that are not actually flooded, and then you've got the Winsford flashes, and then you've got the ones that are over to the going to a Whitegate there, and then the last one go on, which is the Billinge flashes. Now this is the one I'm going to talk about now. So we go on to the Billinge flashes. So the Billinge flashes, if you're a fisherman, it's wonderful. The canal that's the normal width of the canal. It's a regionally important geodiversity site, so it's in the book here. It's a large salt substance trough. The ground is several metres, 7 to 10 metres. The Trent and Mersey Canal bursts its banks, and it goes all the way across. The actual width of the whole subsidence hollow is about half a mile, and it stretches for a couple of miles, something like that. And there's flashes with wetlands. Next one. And if you look at the rail bridge that crosses Watcroft Lane, and also you can look at the canal bridges as well, the bridgework is full of cracks and repairs and held together by ties. You can see that with the original brickwork, but it's all collapsed, and so they've had to rebuild it up in here. There's active subsidence scars and marshy hollows, and the canal banks are collapsing as well. Next one. And unfortunately, it's very costly. HS2 has decided to put their railway line through here. What I've done there is I've put in the railway bridge that occurs at Elworth, Sandbach, where the railway line, the Crewe Manchester line, goes across there, and that is the railway bridge that they have, which is a sacrificial bridge made out of big drainage tubes, so the river, the water can keep on flowing through it, and when it drops they just put more on the top and they adjust it. So I have no idea what HS2 is going to do, but it's going to cost all of us an awful lot of money to get through it. Right, next one. So the Billinge flashes where I'm talking about, in this booklet here, it shows you where to get to. It's number 4. It is typified by sand and gravel, filling a deep glacial tunnel valley, over a brine run, over wet rock head, and shallow salt. If you press the next button, it shows you where the brine run goes, and again, and again. And the brine run, fresh water gets in around the Billinge flashes, it flows under Northwich, and there's springs in Northwich. Oh, we need to go back again as well. Yeah, sorry. Right. So yeah, that's it. So if you just press it once again, and again, that's it, right. So this is a very detailed map here, and it was published in 2014 when a paper was published all about the success of grouting up the salt mines, 3 of the many, many, many salt mines in North which have been grouted. And it shows you the darker the red, the thicker the amount of sand and gravel in the tunnel valley. So we're talking about 60 metres of sand and gravel, and this is the brine run. So billinge flashes, if you just press the button, it will show where the water gets in, a billinge flashes, and keep again, about 2 more, and again. So what happens is the water gets in at billinge flashes. It would have done so from 20,000 years onward, and it would come out in natural springs in Northwich, which is what the Romans and the pre-Romans exploited. And then we've continued exploiting it continuously for 2,000 years. And when the Newmans and Ashton flashes sunk here, all the water in the canal went down, and it was still affecting it up to 10 years ago when the pumping was finally stopped in this area. So there's hydraulic connectivity, is a nice term for you. It's between the water, fresh water getting in here, and brine coming out at the end. Right, next one, and that was 2014, that was published. 100 years ago, Albert Calvert knew all about this, and he had drawn these wonderful hand-coloured cross-sections, which I think are brilliant. And this is Lime Salt Works, Billinge Flash with Northwich in the middle, where the canal is, and you've got the rock salt in a syncline or a downward fold. Water is getting in that end. These are the salt mines here. And if you press the buttons, we should show where the brine run is going, and again, and another one should take us up to there. So you've got fresh water getting in here, getting saturated, dissolving the salt, saturating it, and being pumped out here. And that encouraged the subsidence to take place. And if you press another button, that was subsiding in 2015, it's still subsiding at billing flashes in 2018, and we press it again, and it's still subsiding now in 2018. Next one shows you again why it's subsiding. There have some of the mines, 3 of the mines in Northwich area being filled. This is Northwich Town Centre. We are here, the Adelaide Mine, the Lime Salt Works is here, there's Marbury Country Park up there, and Asda is down here. Very important to know where you're shopping from. These areas here, you can just see some grey areas on there. Those are all open, unfilled other than by saturated brine, unfilled and unsupported other than the few pillars, and it's like 90% extraction. The pillars are about 2 metres by 2 metres, and I'm sure there's people in here who know far more about that than I do. These are all the mines that are unfilled, ungrouted. These are the filled mines there. There's 3 of them down there, and this is Barron's Quay mine, hence the Barron's Quay shopping centre. Which has been built because now the land will actually take construction. And if you just press the bottom, it shows you where the brine run is running through that. So the brine run is still existing and still taking place. And Keele University, as I said, have been monitoring the Adelaide mine in this canal, and it's on the move for the last 25 years. Right, next one. So development in Saltscape is a geotechnical challenge. I've got the substance on here, and I've also marked on where HS2 is going through it. That's the latest bit of development that we're having taking place. So we've got all the substance ones, but we've also, what I've marked on there is the brine cavities and the gas cavities. So if you can press those. So, the salt mine for a start. So we've got dry salt mine here, and then we've got brine cavities at Warmingham. We've got brine cavities, cavities in the salt that are storing natural gas, which is store energy, which is between Middlewich and Northwich. And the next one is the Holford brine field, which John Wilden will no doubt talk about later this afternoon, where there's about 170 or so brine ones there. And then the next one, we've also got World War aviation fuel. I think it was American aviation fuel stored in cavities in Plumley over here, and those cavities are very unstable. So there is a lot of development associated with the salt industry. So if you're going to do anything in this area, you have to be very careful. Right. The next one shows you that the development does take place in Cheshire. It can be done because we understand the geology and we know why and where there's subsidence, and we can come up with techniques of having to sort it out. And this is just to show that dear old Albert Calvert, way back in 1915, he'd already sorted it out. This is basically from where we are here. This is a cross-section showing a brine well that's been sunk down into the lower bed of the Northwich halite through the upper bed. That has been mined out, and that has been mined, and he's very aware that if you start pumping from there, you'll get brine substance either side of where you're pumping. Those distances either side can be miles away from where you're pumping as well. So next one, please. And we can also understand the geodiverse. Oh, if you go back one, sorry, it's clicked. We can understand the geology and the subsidence that's going on in this area. It's really thanks to the white salt industry. It's without drilling the boreholes, doing the mines, we wouldn't know what's going on. It's also thanks to the white salt industry that started by the Romans, I think, when founded by Andrew Fielding. I think that's one of his reconstructions there. So it's like, what did the Romans ever do for us? Well, they did an awful lot for us. They really kick-started our white salt industry, and that method was still using when we're newcomers. We only moved here in 1980, and they were still got pans working here like that, and it was still very much like Roman times. And the Victorians with the Murgatroyd Club had an awful lot of Cheshire folk, and it's Cheshire folk from 2,000 years that have been doing it. And I must admit, I have had a lot of contact with HS2, and I said, why are you putting HS2 through here? Because of the brine runs. And they said to me, what are brine runs? And I said, I keep going to Tesco's and shout out, can you tell me what a brine run is? And I know virtually everybody in Northwich knows what a brine run is. So next one, please. I think that we missed one. Yeah. So I've gone through the geodiversity of Cheshire's salt landscape has left a legacy. The legacy is why we've got these wonderful resources here of salt and reserves. The legacy from 220 million years ago, 2,000 years ago, really kick-started the subsidence, our latest bout of subsidence, and the legacy from 2,000 years of industrial development. And I just love this photograph, this picture of the Winnington Works. It just looks so, I don't know, like a fairy tale castle, doesn't it, or something like that. You know, that thing, we just stick a building on top of those towers there. So, right, and the next one is just to thank you all and to show you some still sinking sinkholes. There's a white salt industry legacy, and that's the area in Wimblesleigh between Middlewich and Winsford. What has happened, there were already brine runs, the actual salt industry has encouraged the development of it, and now we're going through a period of climate change. Water tables are changing, rainfall patterns are changing, the hydraulic system underground is readjusting itself, and these things are still on the move there. Right, so thank you very much, folks.
That's a wonderful introduction, and Ross has finished on time, so I think we've got time for questions. At the very back, yes please.
Right. Ross, you mentioned Melchett Mere.
Yes.
Obviously, Alfred Mond became the first Baron Melchett.
Did he? I
Did
never
he
realised
take his name from Melchett Mere or the other way around?
I don't know. The thing I read was Lord Egerton decided to have one back on his competition briner and decided to call it Melchett Mere. So
What date was that?
I don't know. It's the stuff you find on the internet if you don't read it. But yeah, so yeah.
Okay, thank you.
Oh gosh, yes. Gentlemen there.
There is salt. Yes, they are salty because at Winsford, somebody I know who works for an geotechnical engineering firm, was told to go and check the River Weaver because it was salty by the salt mine, and they found that it wasn't run off from the salt mine. There's a natural brine spring that's going into the River Weaver there, you see. Nantwich as well has got salt-loving plants and those sort of things, but yes, so yeah. I mean, the brine springs, they would have been quite salty pre-Roman times and all that, because there would have been so obvious brine springs on the river banks. That's how they would have known the salt was there. in the hot summers, which was obviously much hotter way back then. But it wasn't. I think in Roman times it was actually warmer than we are now. So if there were a hot day, the brine streams would evaporate and less salt behind.
Yes, where I used to work, rather than being leisurely, I worked for ICL, and we used to go and take our electronic equipment, computers, down the salt mine to get away from electromagnetic radiation. And I believe the National Archives also store their stuff in the salt mine, don't they? Where is that Windsor?
That's Windsor. That was the orange block I showed was the salt mine there.
Yes.
The
That's
salt mine.
dry, is it?
It is dry. It is dry. They did have an incident in 1968. They drilled a whole lot of boreholes in the 60s. There were only 4-inch diameter boreholes to prove where the salt reserves were, and one of them, the backfill of the borehole failed. And luckily, because above you've got the salt that they're mining, which is all dry, above it you've got a brine stream, and then you've got all your loose sand and gravel of this tunnel valley. Luckily, it was only saturated brine that got into it. It was deep enough, you know, they were in waders and they had a boat down there as well. So, I mean, that was 1968. I don't really want to talk about HS2, but they have put the line across the salt mine and they put it so it intersects with about 4 of these 1960s boreholes.
Brilliant.
Well, they can do it. It's going to cost. They know about these things now, but they didn't know about it. So it is worrying that we in Cheshire know an awful lot about the problems of living in this area.
Is that mine at risk, you think, from the changes that happen now, the geological climate changes?
The mine?
Yeah, well, I'm thinking all the...
I think no, because they've mined it so long now, it's been going for over 100 years. They've mined it, they know to keep away from the Billinge Flash area. The mines inspectors reports that say there's that particular area of the mine is very wet, and they've got cavities 5 metres size at the wet rock head. So they know to keep away from that. So then they know that, and it's very, I mean, it's obviously, as climate change, they won't need the salt of the roads, but it's probably even more valuable as a dry storage place, because they keep an awful lot of stuff underground.
Gentleman back row, please.
Your credits to Calvert are absolutely fantastic, because it is a wonderful book and everybody should download that on the interweb. But for the credits, I think you should also add the names of Thomas Ward, who was actually the son-in-law of John Thompson, who managed this salt works. And he published an awful lot of histories of the geology in this area to the Manchester Geological Society and the Philosophical Society. It was his core collection of salt samples that were part of the original Brunner Salt Museum in Northwich. And the archives and the history that were collected by Thomas Ward and by the first town clerk, John Henry Cook, for Winsford, they're credited in the introductory notes of Calvert, but all of the little diagrams that you saw were first published by Thomas Ward in his publications.
Yes, and are they held at the Weaver Salt Museum now?
Yeah, again, lots of those are online. I can send
well.
you the actual links
brilliant.
for a lot of them.
I do feel very much I'm an incomer. I'm a coal mining geologist, used to work in Wigan, you see, in Canada. We just lived here. His husband worked in Stoke-on-Trent and I worked in Wigan, and it intersected in Northwich, so I do feel I'm an incomer here, and there's such a lot of information around.
But he published a diary, again, it's in Calvert, of the collapses of Ashton and Newman's flash, and gives you this vivid, almost daily, weekly description about how the flashes were formed.
Yes, and there's something, is it John Dickinson who's the mining inspector?
Yes.
He's got a wonderful description as well, hasn't he, of how it all tumbled in and
That's right, yeah.
everything.
The big description in the Calvert is the fact that tourists came down to look at this, these great big gaping fissures with water at the bottom, and ministers came and preached on the side of the hole and said, when the end of the world comes, this is what it will look like, except instead of water, there will be fire and brimstone at the bottom.
There's a programme on Channel 4, and I don't know about sinkholes, Channel 5 it is, and they haven't mentioned probably the biggest sinkholes in Britain, which is Newman's and Ashton flashes. I don't know why, but it's something that should be done.
Yes, there's lots of questions, but I'll just pick a couple more. Yes, this gentleman.
You mentioned that there's a hydraulic connection from village flashes. Has anyone got an idea of the rate at which we're doing volume transfer of water?
Well, I think it was hours when the Newman's flashes went down. Again, I think it's reading Calvert and those sort of things, that when the Newman's and Ashton flashes went down, the Billinge flashes went as well. So it's like, what's those pipes called, siphon, that's what I'm trying for, yes, railways cutting me. It's like a siphon, so when you take water out at one end, so all the water was rushing in the mines at Newton, and it was flowing through very, very quickly from the Billinge flash area. So,
And what about now? Is it still moving?
It's still moving, yeah.
I've no idea what rate.
No, well, I think this is where you need the Canal and Rivers Trust to have looked at. It's something I've walked around with. It's what's it called? Peter Stiles, Professor Peter Stiles from Keele University. He's doing the monitoring here, and I've walked around the Billinge flashes and suggested it's an area that they should be monitoring as well. But the rail line, because there's a freight line going through it, they were repairing the freight line bridge at Cropston Lane on Tuesday night. And that's again is in this same Subsidence hollow. So the rail people and the Canal and Rivers Trust hopefully would have something on it. But yeah.
One last question. I'm going to take one from front.
Just a point of information.
Yeah, go on.
You can actually get hard copy of Calvert on has been reprinted.
It has it, yeah. I really feel if they've got Bradshaws for sale here in the railway guide, they should really have Calvert. So, I don't know.
Okay, I think Ros, a second round of applause.